Today we are going to start our new topic. Resistance of a conductor depends on following factors. Questions generally come about on what factors does the resistance of a conductor depends. First factor in this case is length of the conductor. What's written here, resistance is directly proportional to length of the conductor. Both R and L. L is the length of the conductor. They are in linear relationship with each other. As the L would increase, R would also increase. When length becomes double, resistance would also double. When length becomes when length is tripled, or when we will three times the length, then resistance would also becomes three times. Here it is written when length is doubled, current is halved. In other words, resistance is doubled. When we will halve the current using Ohm's law, when you would write Ohm's law is V is equal to IR. In Ohm's law, when we will halve the current, resistance would get doubled. That's the same thing is written here. When here we will halve the current in this equation, when we will halve the current, this 2 of the half will go to this side and the resistance would get doubled. And when the length is doubled, current is halved. In other words, resistance is doubled. It's just the simple case is written. We will take three wires of different length, L2, L3, and up to so on, and then we will calculate the resistance for each of them, for each of the wire. And these conclusions we will get. When length becomes three times, the resistance also increases three times. This implies that resistance is proportional to the length. Now moving to next slide. Next factor is area of the cross section of the conductor. Resistance is inversely proportional to area of cross section A of the conductor. Thicker wires have lesser resistance than the thinner wires. Here it is, R is directly proportional to 1 by A, or we can say that R is inversely proportional to A, where A is area of cross section. Why is it so? Larger the cross-sectional area of the conductor of the given material of fixed length, lower the resistance. Because what's the reason for this? Its reason is there are now more electrons free to move in a conductor. Thicker wire would have more free electrons. More free electrons, they could move in the whole conductor. More free electrons indicate that more current would flow through the conductor and lesser the resistance is. Because in the thicker wire, there must be not that much attractive forces and repulsive forces, and motion of the current or the path of the current is not retarded, and hence lesser resistance is there. But in case of thinner wires, in thinner wire, there is not that much free electrons. In thinner wires, there must be repulsive forces, attractive forces between the atoms of the conductor. In the atoms, there are electrons. In the atoms, there are nucleus. Nucleus of all the atoms present in the wire or conductor, they would attract each other. Nucleus would attract each other of different atoms, but electrons of different atoms of the conductor would repel each other. There are attractive forces, repulsive forces, and the conductor or the thinner wire is exerted upon by various forces, attractive forces of atoms among which they move, and repulsive forces of other electrons. So there are not that much free electrons available. Then thinner wire has less flow of current but higher resistance. Next factor is material of a conducting wire and its temperature. Resistance depends slightly on temperature. Temperature has not that much great effect on the resistance, but here I have not written resistance increases with increase of temperature. As the temperature would increase, resistance would also increase. We are done with three factors, and the first factor was R is directly proportional to length. Second factor is this factor, R is directly proportional to 1 by A. Combining the both factors, we will get R is directly proportional to L by A. Considering this and the previous factor which we have done, it was about length of the conductor. Here is the proportionality sign. To remove the sign of proportionality, we have taken here rho. Rho is called resistivity. Rho is taken here as constant of proportionality, where rho is called resistivity of the given material of the given wire at a given temperature. Next is, here I have just taken the two wires, and please wait for a minute. Actually, I have animated the diagram of atoms here. Okay, we have taken two atoms. The cause I took the atoms to just make it clear why they in the thinner wire there is why in the longer wire there is more resistance in the and in the wire which is of shorter length why there is less resistance. It's just two atoms I have taken just to make it clear to you that how the resistance and length varies. Consider a conductor. This conductor, and in this conductor there are many atoms. I have just drawn some of them, but there are many atoms. Taking the case of the two atoms, here green circle or sphere is nucleus. Blue circles are electrons, and these are shells or orbits. Nucleus, first shell, second shell, third shell. In both these atoms, nucleuses would have force of attraction with each other, and these electrons of the two atoms will have the repulsive force or the force of repulsion in between them. Because of the force of attraction of the nucleus of both the atoms, there is force of attraction and there is force of repulsion. As these are exerted upon by various forces such as attractive forces of atoms and repulsive forces of other electrons, and the flow of electrons through a conductor is retarded. In this longer wire, its length is greater. This green wire has greater length. In this there must be greater forces of attraction, repulsion, and the motion of the electrons is retarded, but in this there is not that much.